Hey, this is Shija speaking, and I will record practical task 8.1 for sit221. So move to question A. So she wants to find a hotel that has the maximum number of shortest paths from the train station. So we can model this city as an undirected graph where each has a unit distance, so the length will be 1. So we solve this question by using BFS, which is it's very easy to find shortest path in unweighted graphs. And in BFS, we keep track of two things for each node. So this and count. So this is the sorry is the shortest distance from the train station, and the count is the number of different shortest paths from start to end. So as we explore each node and its neighbor, so we do the following things. So if it's the first time visiting V, we update this V is equal to this U plus 1, and set the count V is equal set the count U is equal to V. And if we find another shortest path to neighbor, so we add number of paths. So the count U will be equal to plus equal count V. And once BFF is complete, we look for node, which is the hotel with the maximum count value, which means it has the most number of shortest path from the train station. The algorithm runs in n plus m time, which is efficient and meets the problem's requirement. And then move to part B. So we can determine if a communication network is connected by using a DFS or BFS. We start from any node and mark all reachable nodes. If at the end every node has been visited, then the network is connected, and the algorithm runs in n plus m time, where n is the number of nodes and m is the number of edges, and make it efficient for large networks. And then part C. So if a graph is represented using an adjacency matrix, then the runtime of DFS is n squared. Because in that list we only visit the actual neighbor, so the runtime is n plus m. And but with an adjacent matrix, we have to check all n entries in the row of each node. So even if no edge exists, so that will be n multiple n, which is n squared. And then it's about part B. In part B, is back to the question. Like for 3, so it's in 1, 2. So that means from node 1 to node 2, the length is 3. So I draw the diagram like this. It's very messy, but yeah, here's node 1 and node 2. The width is from node 1 to node 2 is 3. And then here's the diagram. And yeah, as every node represents in the question, I finished the diagram. And then move to the second question of that. So the initialization. Um, so just simply steps by step. 1, 2,